finish up talking about the different transformations of graphs. And then on Monday, we'll have more transformations, more graphs that we'll deal with. We'll do the other 4 trig functions. So this particular section is just focusing on sines and cosines. We'll do the other 4 on Monday. Start that on Monday. Finish it up on Wednesday, and then we have our first exam next Friday. All right, so last time we talked about changing the amplitude, doing a vertical stretch or compression. We also talked about changing the period, which is a horizontal stretch or compression. So the other 2 possibilities that we can do, besides, well, we can also do a reflection, but we also talk about doing moving, right? Left or right or up or down, okay? So in these next examples, we're going to talk about what we refer to as the phase shift. Phase shift is just a fancy name for horizontal shift, whether it's moving left or right. The way we can tell whether it's moving left or right is by looking at what's on the inside and seeing what's being added or subtracted in there. For phase shift, personally, I think it's just a little bit easier to do the following technique to figure out how it moves. So when you want to find the phase shift, we're going to set the inside equal to 0 and solve for x. No matter what the inside is. The value you get out of it could be positive or could be negative, so we actually keep the sign in there for the phase shift. So in this case, we would say that phase shift is a positive pi over 4. And since we're doing it this way, the positive really is telling us that we're going to move the graph in the positive direction. Okay? So for this one, your original graph for sine would, remember, it starts at the origin. If we think about I like to think of the y-axis as kind of the starting line. So it starts at the origin, goes up to 1 at pi over 2, down to 0 at pi, down to negative 1 at 3 pi over 2, back up to 0 to 2 pi, and keeps going, and repeats that pattern. Okay. We want to shift it pi over 4 to the right, then I'm just going to take all of these values and move them pi over 4. So that point at the origin will get moved over. This point over here gets moved over. This one gets moved over here. This one gets moved over here. That one goes about there. Likewise here and here and here and here. Like so, that red one. And that would be our final graph then. That okay? We can do the exact same thing for cosine. Again, it's not too hard to solve for x with these, with the way they're written, obviously. But again, if you want to find phase shift, my encouraging thing would be to set the inside equal to 0 and solve. We would actually say here that the phase shift is negative pi over 6. The negative in this case tells you we're going to move to the left. Okay. So again, cosine, if I think again of the y-axis as the starting line, where does your cosine graph start at? At 1, right? Up at the top, up here. So we would have, comes down, goes up, like that, and of course, repeats on that side. We go pi over 6 to the left. Well, pi over 6 is about a third of the way over to pi over 2. So this point would be about here. This one would be about here. This is down at negative 1, so it'd be about here. This one's going to be about here-ish. Not looking for perfection. I'm just looking for you to convey the general idea to me. Okay? This one is about here. about here, here, here. Like so. Questions on that one at all? All right. So when we have it written this way, and it's y equals sine of x minus c, or y equals cosine of, that should be an x minus c. That's a typo. Sorry. That's what I get for not proofreading carefully. That's a typo. That should be x minus c. It'd be a completely different graph the other way. Wouldn't be much of a graph at all, since you'd be trying to solve an equation. Anyway, setting that equal to 0, you would get a phase shift of c, right? So generally speaking, what I was mentioning, when you want to find the phase shift either for y equals sine of something or cosine of something, you're going to solve the equation bx minus c is equal to 0. Okay? Rather than trying to come up with some general rule of how to do it, I think it's just easier to think of it this way. Okay? All right, so let's look at this first example. The first example asks us to find the amplitude, the period, and the phase shift for this negative 1/4 sine of 3x plus pi. So amplitude and period we talked about last time. How do you find the amplitude? What do you look at? Good, the absolute value of that coefficient out in front of the trig function, right? So in this case, do absolute value of negative 1/4, which is 1/4. Remember, amplitude is always positive. So don't say the amplitude is negative 1/4. Okay? It's 1/4. Amplitude, if you think of that middle of the sine and cosine graph, it's kind of like an equilibrium. The 1/4 is saying how far are the top and bottom displaced from that equilibrium. Okay? That is a distance idea. Distance is not negative. Okay? So it's always going to, your amplitude will always be a positive number. Okay? All right, how do we find period again? We look at the coefficient of x, and what do we do with that? You got to do something with it, right? Yes. Yeah, you always divide the 2 pi by that number. Technically, you divide by the absolute value of that number, but we're not going to come across any problems where we make that negative. Sine and cosine have certain properties that you can always take care of the negative in a different way. So we're not going to worry about making it negative. So it's always going to be 2 pi divided by that coefficient. Always. Okay. It's always whatever the original period was and then divide by that number. Okay. So the period for sine and cosine start at 2 pi. This number in here is doing either a horizontal stretch or compression, and it does exactly the opposite of what you think it should, right? We're multiplying the x by 3, so really it has the effect of dividing all the x coefficients or x coordinates by 3 in the graph. Like I mentioned last time, I like to think about it as a speed factor. That 3 speeds up the graph 3 times as fast. So it traces it out 3 times as fast. So the period it's a third of what it started with. The last one now is the new idea. We set the inside equal to 0 and solve for x. Subtract pi and divide by 3. We will get negative pi over 3. And again, it's perfectly fine that the phase shift is negative because we're talking about that gives us a direction in which it moves. If we're graphically speaking, we're going to move that to the, which way? Yeah, to the left, right? It's going to go to the left. Okay. This one didn't ask us to graph it. It just asked for those different pieces. All right. So let's see if we can do one where we graph. Notice this one's got a couple of different transformations. This 4 changes the period, and then we got a plus pi in there, so it's going to change the phase shift. Right? Let's start with our original graph for sine. Sine again starts at the origin. We go up and down and back up, and then likewise so on down the line. Ordinarily, when I ask you to do a problem on an exam, I'm going to ask you to draw me a couple of periods. I'm going to make you keep doing it over and over and over again. I keep doing 2 periods, right? What is the new period for this particular function? Yes. That's the phase shift, but you're right. Yeah, the new period is going to be what? Pi over 2? Yeah, you have a question? Or oh, you're going to tell me. What, sorry, go ahead. So we're going to. What are we going to divide by 4? Okay, so we divide, but what number do we divide by 4? What do the periods start out to be? 2 pi, and then if you simplify, what do we get? That's where the pi over 2 comes from. Yeah. Okay. All right. Yep. Okay. Rather than trying to trace something on top of this that's 4 times as fast, I gave you a little bit of trick to do last time, right? 2 pi is the original period, right? Instead of 2 pi, what is the period now? Pi over 2, right? Half of pi over 2 is pi over 4. And then half of pi over 4 is pi over 8. That'll be 3 pi over 8. 5 pi over 8. Negative pi over 8. Negative pi over 4. Negative 3 pi over 8. Negative pi over 2. So on. All that number does is change the scale. So that's all I did was change the scale. It's a lot easier than redrawing it, isn't it? Yes.
Are we always able to use this method, or is it like sometimes on the page you should be like just adjust it based on the graph?
Nope. Okay. You always use this. Yep. Okay. Those for the amplitude and the period change, you can always do this. Okay. Yeah. Now when we get to shifting, we actually have to shift it. But for the scale changes, we can just change the scale. So far, so good? Okay. Now for the phase shift, you told me what the phase shift was. What was it? Negative pi over 4. Good. So if you remember for your phase shift, we're going to set the 4x plus pi equals 0 and solve. So our phase shift is negative pi over 4. And in this case, the negative tells us we're going to shift to the left. Good. Pi over 4 units. Yep. I've got the new scale, so I'm going to shift according to that new scale, right? So when I shift, I'm going to shift everything pi over 4 to the left. So this point at the origin is going to end up right here, isn't it? This point at the origin is, well, this point is going to end up here. This is going to end up here. This one will end up down here. This one will end up down here. This one will be up here, and you get what looks like we just took the graph and flipped it upside down. But again, everything is moving left pi over 4. So this point went here, right? This point went here. Probably a little easier to see where those points went to than looking at the ones on the origin because they look like they just landed on top of each other, right? This point went here. This point would go over there. Right? Everything's going to the left pi over 4 units. That okay? We can do the same thing for cosine. Cosine, again, if I think of the y-axis as the starting line, where does it start? 1, right? Starts up here, down to pi over 2, negative 1, back up to 3 pi over 2, 2 pi. So, again, not looking for perfection, just looking for the general idea. Again, these would come back down and hit the x-axis at 5 pi over 2 if you really wanted to draw it, right? This is going to come back down that way, that way. Again, we should recognize 2 changes here. We've got a period change and a phase shift, right? How do we figure out the period again? What do we do? Yeah, 2 pi divided by what in this case? 1/2, good. Because it's a 1/2 x, right? So we'll take the 2 pi divided by a half gives us 4 pi. So again, one period before went from 0 to 2 pi. So instead of this being 2 pi, this should now be 4 pi. Halfway in between is 2 pi. This will be pi. This will be 3 pi. And we'll have the same thing on the other side. Just be negative. I mean, if you really want to retrace out the graph using the original scale, you can. I just think it's harder. It's much easier just to change the scale. I'm changing where the 2 pi was to that number. I'm just changing the scale. That's all it's doing. Okay. The other piece of information we see is that phase shift. How do we find the phase shift again? You have to be really careful when you write the word shift. You don't want to forget any letters. Same thing with secant x. The way we abbreviate it, you don't want to accidentally forget a letter in there either. Because people giggle at you. Okay. How do we find the phase shift again? Yeah, solve for the x, right? We set it equal to 0 and solve. So x over 2 minus pi over 6 equals 0. Add your pi over 6, multiply by your 2, you get pi over 3. Which way is it going to get? When we shift, again, the phase shift here is positive. That's fine. Literally, the number is the phase shift. Okay? Whether it's negative or whether it's positive. Which way are we going to shift the graph since it's positive? To the right. Good. So everything's going to go right pi over 3. Pi over 3. Notice that this scale now is pi here, right? So pi over 3 is a third of the way over to the right. So this will get moved over a little. Let me change the color. Sorry. It's a little bit easier to see. This will get changed over there. This gets moved over a third of the way. This gets moved over a third of the way. Third of the way. Third of the way. And we get the same exact graph, just offset a little bit. That's why we call it a phase shift, right? It's just been moved a little bit. Questions on that? the last thing we notice, and I'll probably do one more example here, and then we'll do a couple more examples on Monday since I want to make sure we have plenty of time to take a quiz. Last thing we talked about are vertical shifts. Notice in this case, I write it on the other way. I write the number out in front rather than on the end, so that we're not confused on whether or not it's inside the sine function or outside the sine function. That's why I got it written in front. Okay. Again, the number there is telling you how far up or down you go, just like it did for when you did transformations of graphs in algebra class. Same idea. So the vertical shift is just the number. If the number is positive, which way does it go? Up. If it's negative, it goes down. Good. So for this one, be careful. I changed the I changed the vertical scale on this one from the previous graphs. There's what the original sine graph looks like. Which way am I going to move it? Up 1, right? So this point at the origin will get moved up to 1. This point at 1 will get moved up to 2. 1, 0, 1, 2, so on and so forth. I should have hit the origin. That was a bad. So on. Does that make sense? Nothing fancy, right? So you would do the exact same thing for the cosine, except in this case, what would you do with the original cosine? For the second example that we have in there. What would you do with the original cosine graph? Down a half of a unit. Yeah. Good. So like I said, I want to make sure I have plenty of time for your quiz here. So we'll do more of these, put everything together next time, as well as start talking about graphs of other trig functions, the other 4 trig functions. We won't focus as much on the transformations of the other trig functions like we're doing here with the graphs. We'll focus more on just what the graphs are. We'll talk a little bit about it, but we won't focus as much on it. So.